Okay, see in this question what they have said. For in the first part we have to calculate equivalent resistance between terminal A and B. Okay, this is terminal A and this is terminal B, so we can calculate the equivalent resistance. See how can we get the equivalent resistance? Just imagine that you are standing at the A position and you need to move towards B, right? You need to move towards B. So whichever resistance like I told you, just imagine that all these are your friends. So whichever friend is in the same path, these resistances in series, otherwise they are connected in parallel. And we'll start with a friend who is very far away from you. So from A, which friend is far? That is 12, right? With 12 we are having 8 ohm, right? So tell me, 8 and 12 is in series or in parallel? It is in series, so if we'll combine it, it will be converted into 20, right? So consider only one resistance, that is this would be how much? 20 ohm. Okay, now tell me this 3 and 3, it is in series or in parallel? 3 and 3 both you can go to the same time, right? So it's in series, so again we can consider it as single resistance, that is 6 ohm. So now we can consider this. Now the circuit would become like this. I'm redrawing the circuit so that you won't get confused, right? This is how the circuit looks like. This is 12 and this is 6. We can see that these two resistance is in series or in parallel. It is in parallel. Do in your syllabus do you have star or delta? Star delta transformation. Okay, so 12 and 6 is in parallel, so it can be combined with a single resistance, right? So this resistance would be eliminated. Now these two resistances in series, right? And then we can combine it with this, then it will become in parallel with these resistance. Then after solving it, a single resistance will be there, then these two resistance will be in series, right? So we got our first answer. Now the second answer, the power absorbed by 1 ohm resistor if terminal A and B is connected with the voltage source of 24 volt, means they have connected a voltage source over there of 24 volt, and the power absorbed by 1 ohm resistor. We need to calculate the power absorbed by the 1 ohm resistor. Okay, for the power, what is the formula? That is I square R, right? So they have given the value of resistance is how much given, they have, that is 1 ohm, right? If we'll get the value of current across 1 ohm, then we'll get the value of power also, right? And they have given the voltage also, right? That is how much? 24 volt. So you can simply calculate the current by using Ohm's law. Okay, like in this case you combine it over there, like I told you, the circuit diagram would become like this and this, it is in series, that is 6 ohm. 6 and 12 is in, it is in how much? 6 and 12 is in parallel, 6 parallel 12, right? 1 ohm will remain as it is. Now here this is 12 ohm. So you can apply a current division rule also to calculate the current in 1 ohm, right? Remember the current division rule? In the current division rule there is a formula, actually I'll tell you that. Suppose this is the circuit and we want to calculate I1, I2, I, and we want to calculate I1. What is the formula for I1? That is total current. Total current is here, here is how much? I, then multiplied by the opposite resistance in which we need to calculate current. We have to calculate current in I1, so opposite resistance of I1 is how much? R2, right, divided by sum of resistor which are connected in parallel. So it would be R1 plus R2. So if we know the value of R1, that is good, R2 is good, okay, this we can consider it as R3, but there is no role over here in R3. Now if they have given the current value, then it is good. If they don't give the current value, then we need to calculate current. Total current is how much? Total voltage divided by total resistance, right? Voltage they must have mentioned, that is in this case also they have mentioned how much it is, 24 volt, right? And total resistance we can calculate it, that R1 and R2 is in parallel, so R1 into R2 divided by R1 plus R2, then it is combined in series with the R3, then it is combined in series with the R3. So by putting the all the values of resistance, we'll get the value of current, right? And we can substitute the value of current over here, then we'll get the value of I1, right? After getting the value of I1, we'll get the current in 8 ohm, and we can put the value of current over there, then we'll get the power of the circuit absorbed by the 1 ohm resistance, right?